An alumina crucible may look simple, but the real test starts when heat, sample chemistry, and repeated use come together. A small mismatch in purity, firing quality, wall consistency, or working temperature can affect contamination control, dimensional stability, and process repeatability. That is why a reliable crucible is not just a ceramic container. It is part of the heating process itself. In the next few minutes, we look at ADCERAX alumina crucibles from this practical engineering angle. Alumina crucibles are not limited to one geometry. Cylindrical shapes support general calcination and easy powder loading. Rectangular forms improve furnace utilization in parallel batchwork. Boat or round-bottomed forms can help sample melting and liquid handling when wider exposure is useful. 96%, 99%, 99.5%, 99.7%, and 99.9% alumina grades are available. Routine calcination may use 96% or 99% material. Thermal analysis, precious metal testing, or sensitive precursor calcination normally require higher purity to reduce impurity pickup and keep the sample interface cleaner. For 99.7% alumina crucibles, the maximum operating temperature is 1730 degrees Celsius and a safety temperature range is from room temperature to 1700 degrees Celsius. The material melting point is about 2050 degrees Celsius. Actual service life still depends on heating rate, atmosphere, sample chemistry, and thermal cycling. These crucibles are used for laboratory calcination, etching and loss on ignition testing, catalyst preparation, ceramic powder sintering, thermal analysis, and selected small batch melting work. The important decision is not only the shape. Engineers also need to match purity, lid style, volume, and surface finish to the working condition. Geometry matters because wall thickness, rim flatness, and lid seating affect heat distribution, vapor control, and repeatable mass balance. ADCERAX can support machining up to plus or minus 0.1 mm. For covered crucibles, a stable lid fit can reduce drafts, vapor loss, powder lift, and splatter. Alumina crucibles begin with prepared alumina powder, which is mixed and granulated for stable forming. The powder is shaped into round, square, arc, or custom crucible designs while controlling wall thickness and rim structure. After binder burnout, the formed body is sintered at high temperature to develop ceramic strength and dimensional stability. Final machining, edge finishing, surface treatment, and inspection help each crucible meet its intended laboratory or thermal processing use. For standard purchasing, ADCERAX lists common stock sizes from 5 ml to 1000 ml, plus TGA and DSC micro crucibles. The broader category range covers 3 to 4000 ml. In stock, standard items can be prepared quickly, while non-listed dimensions move into engineering review and custom production. Shape selection should follow sample behavior. Cylindrical low-firm crucibles support fast heat-up and simple loading. Stepped lids help volatile samples and draft control. Rectangular crucibles help parallel design of experiment or batch furnace runs. Pointed bottom crucibles concentrate residues for trace recovery. Alumina is stable in many high-temperature processes, but it is not universal. Alumina may not be suitable for melting reactive metals such as titanium, zirconium, and rare earth materials. It is also attacked by hydrofluoric acid and hot phosphoric acid. When thermal shock resistance is the main priority, the material choice should be reviewed before production. To request a practical quotation, send the required alumina grade, volume, shape, lid style, dimensions, tolerance, quantity, operating temperature, atmosphere, and a drawing or sample if available. ADCERAX engineers can review standard sizes and custom crucibles for laboratory, furnace, thermal analysis, and high-temperature processing needs.